in this lecture, we'll keep working on the geometric sequence. You see down here, we have R is again all the time the next term divided by the previous term. Okay? Don't get confused. Next term divided by the first term. Actually, you can use, the third one divided by the second one. You'll get 2. Okay? That's why we say the ratio is common. That's in geometric sequence. In arithmetic sequence, the one number minus the previous term is a constant. Here the ratio is a constant. There the difference is a constant. Okay? Now we know R is 2. And this R is greater than 1. Alright? Yeah. Here you may say R equals 2 greater than 1. And then if it's greater than 1, you have a what? You have a R squared is 2 squared is 4. And R to the 5th is 2 to the 5th. That's what? 32, right? Yeah. You may do more. R to the, how many? Let's say R to the 20th. You may choose 20. You may choose 30. It doesn't matter. Okay. So the thing is that I want everyone to understand. Let me put right here is 2 to the 5th. We know is 32. 2 to the 20th. That's even bigger. Oh, very big. 1048 576. Okay. So basically you see is R to the n goes to infinity. Very big. Gets bigger and bigger. You see? When n gets bigger and bigger. Okay. So then you see our formula was S sub n equals a1 and 1 minus R to the n over 1 minus R. Here, when n gets bigger and bigger, R sub n gets bigger and bigger. So here is actually tells you that the numerator gets bigger and bigger. The rest of them, are constants. So then, I got to drink some water. So then, this is not going to converge. This one goes to infinity as n goes to infinity. Okay? So then you may say the sum does not converge. So we can only find the sum when R is less than 1. Okay? Yeah. And if R is bigger than 1, we are not able to find it. Okay? You may say, how about 1? We cannot find out that the infinite sum, even R is 1. It also does not converge. Why? Look, 1 minus 1, denominator is 0. Okay? So it's like what? If here is R is 1, every number is the same. 4, here would not be 8, here will be 4, 4, 4, 4, 4. You add many 4, it's still an infinite number. It goes to infinity. All right. Yeah. So this one basically tells you, us to remind you that R is calculated in this way. Following 10 divided by the first 10. And when R is greater than 1, it's not going to converge. Oh, that's not, you see. I want to circle it. Does not converge. Don't need this S. I will get rid of this. Huh. Okay, now let's look at the second example. This is the application. Huh? This one says a population of fruit flies is growing in such a way that each generation is 1.5 times as large as the previous generation. Suppose there are 150 insects in the first generation, and how many would there be in the fourth generation? So, you know, in this case, it tells us is R is 1.25. Okay? Because it is clear, this one tells us. Okay? Yeah. All right. The second one, this one tells us was the first generation. So then you have A1 is 150. Okay? And then ask us to find out the fourth generation. So you're going to use the formula. What is our A4? A4 is A1 times R to the not fourth, or is less than, one less than the index here. All right, that will be 150 times 1.25 cubed. Okay, so what do we get? 150 times 1.25 cubed. Hit enter. This number, it has decimals. So let's get an integer, because you know the number of insects needs to be an integer. Okay, so we probably don't say 0.9 insect. And based on the answer right here, we say 293, because this one is greater than 5, 9. So that's what you need. Okay? So, please review this lecture. I'll see you next time.